Good afternoon, this is Mr. Precella. Today we're looking at solving inequalities using cut points, also known as the cut point method. And it's one of my favorite assignments in this course, believe it or not. Let's see.
Before we actually start that, let's review, just make sure y'all remember something we did at the very end of class last time. This review, I say review, somewhere along the way you saw it, you may not remember it then. Something called interval notation, where we're talking about numbers, sets of numbers on the number line. Like I've shaded all the numbers between -5 and -1. The closed circle means including the number. An open circle at the number means not including. So this region here is all numbers between -5 and -1, including -5, not including -1. The green region is all the numbers between 2 and 4, not including 2, not including 4. There's a lot more than just 3 if you think of all the decimal numbers there. And then the last shaded region are all the numbers bigger than 6. We could say, I guess, between 6 and infinity, including 6. It doesn't make sense to talk about including negative infinity. Positive infinity. Why to say negative infinity? With interval notation, you put square brackets at the closed circles and parentheses at the open circles, and always put parentheses at infinity symbols.
I should mention something. You may see if you're viewing an example, somewhere along the way, in the first decade of the 2000s, people started putting the brackets, okay, there's the closed circle. They would put a bracket there in place of the closed circle. The problem with doing that is you don't know which direction you're going to be shading. When you label those cut points on the number line, well, are you going to be shading to the left or to the right? Should the bracket face left or should it face right? That's the problem there. But there may be some examples. I even think there's a problem. They show number lines in one of the homework problems, and I think they're putting brackets for closed circles, and in place of the open circle, they had a little parenthesis there. That became popular during the first decade of the 2000s. They're moving away from it now because they finally realized, wait a minute. You're labeling those numbers, but you don't know whether you're going to be shading to the left or to the right. So how do you face the parentheses, left or right? So anyway.
And going back to what I mentioned before we started recording, I like names. These numbers that we have here on the number line with the open and closed circles or parentheses, we call those cut points. Also, just remember something else we did the last time. To solve an absolute value equation, you've got to have the absolute value bars isolated. And then if there's a positive number on the right, you go equal positive, equal negative. If there'd been a negative number on the right, then there'd be no solution or empty set. So that's just what we did on Monday.
And it will be important today.
Once we get to problem 7, I think. We are now...
I thought it was 8.
Okay.
Maybe it's 7. Oh.
We're going to solve inequalities. An inequality is something that has a less than, a greater than. It might have a less than equal to or a greater than or equal to. It's always important to be able to distinguish one type of problem from another.
Not focusing.
Oh, it's not focusing?
Yeah, don't you see it? Just...
Oh, then put it on lock. Oh, okay. It's always important to be able to distinguish one type of problem from another. So far this semester, we have not seen anything with less thans or greater thans in it. If you see something with a less than or greater than in it, and it says with the instructions solve, you're going to be doing that cut point method.
This is what I was talking about as class was starting. You ask yourself, when is the inequality equal to? Where is it undefined? That's what you're doing in step number 2. Anywhere else, it's either less than or greater than. You draw a number line, label those cut points. and test the intervals on the number line. And notice step number 5, express the shaded intervals using interval notation, and we're reminding you, square brackets for closed circles, parentheses for open circles, and parentheses for infinities or negative infinities. So
if you start solving these and you think, oh, I can do these without drawing a number line and shading regions,
intervals,
well, regions on the number line, then you're wrong. Whatever you're doing, you can't get it done. You've got to draw the number line and test regions. And I think the last two problems, 11 and 12, should convince you of that. But let's just start with problem number 1, and we'll read through the recipe as we go along. It says, solve this inequality. Write your answer in interval notation. Problem number 1. What is it? X squared minus 15x. Is that a plus 54 is greater than 0? Now, it says solve the following inequality. At no time will it ever say, do the cut point method. Okay? You've got to know, oh, that's what I'm supposed to do, is this stuff right here. And you know, it's more low tech, but I'm going to just be flipping back and forth with the paper team. Step 1, replace the inequality with an equal sign and solve for x. We'll call these numbers solution cut points and abbreviate them SCP. We can do that.
They're solutions to the equation, hence solution cut points.
So step 1, this is probably the only time I'm going to label the steps like this. Replace the inequality with the equal. And we now have an equation. In fact, it's a quadratic equation. So what are the two methods we've been using primarily for solving quadratic equations? Quadratic formula or factoring. Perfect. Well, which one do you think I'm going to do? I think I'm going to factor it. Rather than writing out all the numbers that multiply together to get 54, there's one pair that stand out from the multiplication tables. It's not 1 and 54 or 2 and 27. There's another one. Can y'all think of 6 times 9? Why am I thinking that's going to work?
That's right, because 6 plus 9 gives you 15.
Okay.
That's how I do it.
So, x and x. Now, what about our signs here? The second sign is plus, so 2 of the first, so 2 negatives, and 6 and 9. If you FOIL that out, you have x squared, then minus 9x and minus 6x would combine to give us the minus 15x and 54. So we factored it correctly, set each factor to 0, move the 6 over, we get x equals 6, and what's our other cut point here? X equals 9. Reading our little recipe, we call it a recipe because if you follow it exactly, miraculously, you'll have an answer at the end.
Correct.
The correct answer. Okay? So, replace the inequality with equal, solve for x. They're called solution cut points. Now to decide, is it going to have an open or closed circle? Could y'all read through this recipe and figure out what it's saying? Is it going to be an open circle or a closed circle? If the problem has an equal sign on it, closed. If it doesn't, open. So you are right. There's just a greater than, so it's going to be one of those little open circles.
Label SCP for solution cut points.
Wouldn't that be an open?
Yeah, open. Uh-huh.
Okay. I heard closed. I was like,
Oh, did I say? Oh. instead of saying step 1 after this, I'll just be labeling SCP for solution cut point. Okay? Now, step 2, set any denominators not equal to 0. Solve for x. These are called denominator cut points. We'll abbreviate them DCP. Always label denominator cut points with an open circle. Well, there's no fractions in this problem. If you don't see any fractions in the original problem, then you'll skip step 2. I'm just going to say for step 2, no denominator cut points. Can you get rid of this pen? Is this a black one? Mm-hmm. Because there are no denominators.
There are no.
Yeah, let's say no fractions. That's a better way of wording it.
Okay.
There's no denominator cut points because there's no fractions in the problem.
In the original problem, you could have had a solution cut point of 6/5. It's the original problem of which there are no fractions.
Step 3 says, draw a number line and label those cut points. So I'm going to draw a number line. I'll go ahead and label the arrows as negative infinity and positive infinity. Here we only have 2 cut points, 6 and 9. Make sure you put those numbers in numerical order. You might laugh at me saying this, but if you put the 9 here and the 6 there, then
Is that a negative 30?
a negative
Oh,
30.
that's an infinity on both sides.
Oh yeah,
Open circles.
oh, I was waiting. Oh no, I was about to do that. Label each of these with the open circle. And step 4. We're now going to decide how to shade the intervals. Once we've shaded regions on here, we'll be finished except for writing the interval notation. So step 4, select a number in each interval and substitute it into the original inequality. If the inequality is true, shade the region. If the inequality is false, cross out the interval containing the test value. So notice how this is broken into 3 regions. Mm-hmm.
What does it mean that if an inequality is true or false?
Oh, plug in. Choose a number between negative infinity and 6. Any number on the number line?
0.
Oh, okay. So I'm going to test 0. When you plug 0 into the original problem, you're going to get a statement, some number greater than 0. So plug in a 0 in here. 0 squared is 0. 15 times 0 is 0. Plus 54 is greater than 0. So the statement you have is a 54 is greater than 0, true or false? True. Do you see what I mean by true or false? 54 is bigger than 0. If it had been...
Oh, it's bigger. That's, okay. Okay, I got you. Got you.
So if it's true, shade the interval. So
I got you. If it's lesser or greater than, if it's wrong,
Mhm.
I got you. That makes sense.
now let's test that next interval. Here, over here, between negative infinity and 6, there were a lot of numbers you could test. Here, there's not a lot of integers that you would, numbers between 6 and 9, which one do you think we should test?
I'll give you a hint. Either use 7 or 8. You could use 7.43592, but Use something easy. So, what do y'all think? 7,
Seven.
okay.
I'm testing 7. Now this one's going to take a little bit more work. 7 squared, 49 minus, 15 times 7, is that a 70 plus 35, is that 105? Ooh, plus 54. Ooh, I'm running out of room. Is it greater than 0? Well, let's first of all, 49, I think like 49 minus 105, or do we want to add 49 and 54, or do you just want to stick it into your calculator? What are we going to get here? Are we going to get a positive number or a negative?
So 103 minus 105, so I'm getting a negative 2.
Mm-hmm.
Does anyone want to check me there? Okay. True or false? Negative 2 is greater than 0. True or false? False. Cross it out, or write F.
There. And if you were given a true-false test and someone told you beforehand the answers alternate, what would you, if someone said the answers alternate, what do y'all think the next interval is going to be? True? Most of the time, these things alternate. If you find yourself getting 2 falses side by side or 2 trues side by side, you're probably messing up.
Odds favor you've messed up then.
In a moment, I'll tell you how you can look and decide if it alternates with 100% confidence. Mm-hmm.
If 7 doesn't work, then 8 automatically doesn't work too.
Right. In fact, every number, every decimal number between 6 and 9 will not work. 6.123 will not work.
So what happens after that?
Well,
None of
go
those
on
work.
to the next
We go on to the
interval.
next interval.
No numbers between 6 and 9 work. If he had tried 6.43279, it would not have worked.
But
the only time it can change from true to false is if the inequality is equal or if it's undefined. It cannot change between 6 and 9 because there's not another spot where it's equal or undefined. It may change at 9. Okay, so let's see. What do y'all think is going to happen here?
choose any number between 9 and infinity.
Something easy to work with. 10. I think 10's a good number to use.
And I missed what you said. And if 10 is true, this is amazing. If 10 is true, then it would be true. Every number between 9 and infinity is true. If 10 is false, then every number between 9 and infinity is false. Or else you messed up. So plug in a 10 in. 10 squared is 100 minus 150 times 10, excuse me, 15 times 10 is 150, plus 54. Is that just a 4? 4 is greater than 0, true or false? True. That means every number here makes it true.
If I plugged in 50 million, would it be true or false? True, because it's way out here.
So.
And by the way, label step 4. All that testing is step 4.
Uh-huh.
So how would you answer this?
Well,
we're about to do it. Step number 5.
What we were reviewing at the end of class the last time, we now have a number line, just like here. This is the number line we have right now, but this is what we did the last time. You take the shaded regions, write them in interval notation, connecting them with a big U called a union symbol to show that they're all on the same number line. So, how would I write this first shaded interval in interval notation? This is step 5.
Realize you're going to have to type the answer in. You drop a parenthesis or a comma, the answer is wrong. So, for this first interval, what's the first symbol I would type? Well, before negative infinity.
Let's go ahead. Negative infinity to 6.
What's going to go in front of the negative infinity?
Parentheses or bracket? Parentheses. Always put parentheses in front of infinity symbols. Always use parentheses for open circles and brackets for closed. So
does that 6 become closed? Because
no, it's an open circle. It stays.
it stays. Okay.
Right. Then we write the U, the big symbol union.
That'll be on the toolbar. The union symbol will be on the toolbar. You don't use a U from the keyboard.
Now, what's the next interval? Well, don't use 6 to 9. You're using the shaded intervals. So how do I type this next interval? What's the first thing I do? Before I write a 9, what do I write? Parentheses 9, comma, infinity, parentheses. So, in words, what's the solution? Every number between negative infinity and 6, not including 6, and every number between 9 and infinity, not including 9. And I don't even need to say not including infinities, do I?
Okay. I would not use these parentheses symbols here on the toolbar. That's for an ordered pair, and we may have things that start with a parenthesis and end with a bracket. So I don't use those parentheses and brackets on the toolbar. I use the parentheses and bracket from the keyboard. So I go a shift there, I got my parenthesis, and notice there's only one infinity symbol on the toolbar. I'll get emails from students, there's not a negative infinity hot button. You're right. If you want negative infinity, you have to type the negative from your keyboard and then click the infinity symbol, comma, 6, right parenthesis, union. Notice if you hover over that, it says union. This symbol here beside it is set intersection.
If you find yourself ever using that in this course, you're doing something wrong.
And then left parenthesis, 9, comma, infinity, right parenthesis, check answer.
This is an amazing little sequence of steps. It will solve. Oh, okay.
Okay. I just pulled it up,
and
I wanted to point out. You're asking me.
They went to the PDF.
Oh, I did go to the PDF. Oops. I wanted to point out. Number 1 is asking, when is it equal? Number 2 is asking, when is it undefined? Well, the stuff that we've been dealing with that are undefined are fractions, but if you were dealing with a trigonometric function, you could still adopt this method, this thing. It's asking, where is it equal? Where is it undefined? Everything else, label your cut points and test intervals.
Let's do number 3 now.
Number 3, let's see. Okay, hold on. Oh, I thought that number 1 was pretty short.
Yeah, number 1 was short.
I thought that was the short one. Wait a minute. We have a different definition of pretty long, okay? Number 1 was the short one. And when I look at this number 3, as you look at those steps, of the, did you write it down? You got it written down?
X and X minus 3 is less than or equal to 28, yeah.
As you look at that second step, remember the first example we did, we just skipped that second step. Are we going to have to skip the second step here? Once again, I agree. Now,
you know what, let's write on here.
Generally,
skip if no fractions in the problem.
When I'm teaching this class by myself, I start at number 5. That's the first example I do.
Well, this is
because
what I've
this
always
is
done.
Yeah, I mean,
but today I'm doing something different. We're doing something different.
But
Yeah,
What
number
about
5
this
is the
one? Do you
best
think you'll
example.
skip number 2 here? No, because there's a fraction. When there's a fraction in the problem, then you have to do number 2. When there's no fraction in the original problem, there's no denominator cut points, you just skip it, okay? So don't be thinking step number 2 is something you just always skip. No, that's not the case. Let me go back to number 3. And there.
Well, we're going to find the solution cut points first. So I'll label SCP. First step says replace the inequality symbol with an equal sign. So we have x times x minus 3 equals 28. Now, oh gosh, how do we solve this equation? Well, it's actually amazingly like number 1, except there's one extra step on number 3.
what are we going to have to do?
Yeah, you got to distribute this x. So we'd have x squared minus 3x equals 28. Another one of those quadratic equations.
There's only one correct next step. What is it? Whether you're going to solve it by factoring or the quadratic formula you... Okay,
Yeah.
good. Subtract
Did y'all
28.
hear that? Move that 28 over by subtracting 28 from each side. And let's see, how are we going to factor this one? X and X. Hey, do I know the signs? I mean, can I fill them in? Is it 2 pluses, 2 minuses, or one of each? Yeah, one of each. If the second sign is minus, 1 plus, 1 minus. So we'll wait to fill it in. Numbers that multiply together to give 28. There's 1 times 28, 2 times 14. There's another one. 7 and 4. Is that the one you're thinking will work? 7 and 4. Now, in order to get a negative 3x, how should I arrange my plus and minus?
Good.
Did y'all hear that? Negative in front of the 7, plus in front of the 4. If it's been a while since you've had other math classes, then factoring is one of those things, just the more you practice at it, the better you get.
And by factoring, I can tell you with 100% certainty that it will, looking at that factorization, I know the intervals on the number line, it's either going to be true, false, true, or false, true, false. There is no way you're going to have true, true, false, or false, false, true. I'm 100% confident there's only going to be, it has to alternate, so I don't even have to check every one of the intervals. I can check one interval and assume an alternating pattern.
Here's the statement. I should have already written it. Thanks for reminding me, Tina. If there are
I thought you
no
were just waiting for the punchline. I didn't
repeated
know.
factors, then it alternates.
Then you can assume an alternating pattern.
Now, what do I mean by repeated? Well, if we get the same thing in both sets of parentheses,
X minus 7 times X minus 7. Or
then
X
it
plus
might
4,
not
X
alter.
plus 4.
Okay?
In order for that to happen, this number has to be a perfect square, though.
So,
And
So-
28 isn't a perfect square.
like over here, I knew as soon as we did this one, did we get the same thing in both sets of parentheses? Nope, I knew it was going to alternate. Okay? If you've gotten the same thing in both sets of parentheses, then you really need to test every interval. But more than likely, if you do that, if you got the same thing in both sets of parentheses, more than likely you've messed up. Okay, so now set each one of these to 0, and what are we going to have?
7 and -4.
Yes, x equals 7, and x equals -4. I'm listening.
I'm just trying to figure out the factoring, because you have x minus 7 and x plus 3, but that
No,
Oh, right.
and X
7
plus
and
4.
X or
Where's the
3x,
3?
Which doesn't equal 28.
It's 4.
Where?
Negative 7 plus 4 equals
I have a 4 here.
I know, but you put the inside, it's negative 7x,
Oh,
and you put the outside, it's x, or 4x.
Negative 7x plus 4x would give us a negative 3x.
Because 7 minus 4 is 3. I'm just remembering.
So we have a negative 7x plus 4x, negative 3x. And so these two middle terms here, and I didn't show that, add together to give them the middle term here, negative 3x. But these last two terms, those should multiply.
This mixed with 3 and the 28. I think I have number dyslexia sometimes.
Oh.
Because I mixed the two up. I had the 28 in the middle and the 3x on the.
Oh,
so I was
okay.
factoring it incorrectly.
Oh.
And I'm like, what? Okay, it makes sense.
Oh, okay.
Sorry about that.
No, that's okay.
Open or closed? For the solution cut points, how are we going to label them on the number line? Closed.
You look at the original symbol. If there's a equal sign on it, closed circle. Years ago, a really good student said,
That doesn't look closed to me. It
Oh.
still looks open.
oh,
There.
a really good student said, here's how you can remember.
I hope it's not
Yes.
vulgar. If it's vulgar, don't say it.
No.
Oh, okay. I had a student once volunteer a little vulgar thing to class, and I was like, oh, I'll never ask students to tell me, how do they remember this? Okay, go ahead then.
But it had something to do with the horizontal line. I remember
there's
that.
yeah.
But anyway, this one, if you're going to write these symbols, less than, equal to, greater than or equal to, less than, greater than, which ones take more ink? The one that has the equal sign takes more ink to write. What about the circles? Which circle takes more ink? The closed circle or the open circle?
Okay.
The closed, so it's just which one uses more ink. I thought that was brilliant when the student said it. Now that I'm saying it to y'all, it sounds really stupid. But that's what she said, and I was like, oh wow, I'm going to remember that. Which one uses more ink? The one with the equal sign would use more ink. So the circle, the closed circle, uses more ink. That's how it goes. Okay?
Tony, the students in the peanut gallery are shaking their head. They're going to stand up and leave with your nonsense, okay? So,
Okay.
let's keep going.
We skip step 2.
Because there are no fractions in the original problem.
Draw a number line. I'll use green. Now here,
It actually kind of does make sense, though.
oh, okay.
You'd
Thank
be
you.
surprised how many
Just saying,
people.
I'm like, turn red. I'm like, oh, that's kind of
You label the numbers in numerical order, not in the order in which you write. You laugh, but so many people would put 7 and negative 4.
Then it's just going to be such a mess.
Yep.
So how should it be labeled? Negative 4.
Yes.
Negative should always be to the left of a positive. And what did we say? Closed circles on those? Let me see if I can draw a closed circle. There. Now, instead of doing what I did on the previous one, where I chose a number from every interval, I'm only going to choose one number and one interval to test. If we look at these, which of these was the easiest one plugging in?
What number's the easiest to plug in?
0.
Well, I think 0. You may say 1, so you can test 1, but if it's up to me, I'm going to test 0 unless 0's a cut point. If 0's a cut point, you can't test it. But in that event, I'd probably choose 1, okay? But for anything, which interval contains 0?
Is 0 between two negatives? Or is it between a negative and a positive? Or is it between two positives? It's always between a negative and a positive. This is the interval that has 0 in it. That's the interval I'm testing. I'm either going to shade this interval or cross it out. If this interval's true, I'm going to mark the other two as false. If this middle interval is false, I'll mark the other two as true. Okay? Is it clear why I'm saying this is the interval that has 0? 0 is always between a negative and a positive. Remember the semester the student said, wait. Over here, 0 was the first interval. Over here, you're saying it's in the second interval. And then the student snickered and laughed, and I tried to, okay, good question. Notice 0 is always between a negative and a positive. It's never between two positive numbers. It's not between two negative.
Okay, plug in 0.
So I'm putting a 0 in for this x. We'd have a 0. Now, what would we have in the parentheses? 0 minus 3 is negative 3. Oh. Now, let's see. 0 times negative 3, is that going to be just a 0? Is less than or equal to 28? It's sure not equal to it. But is it less than?
Yes.
So true. That means I shade this interval. And what do I do with the other two? False? False. Okay, because these alternate. Will I have a union symbol in my answer here?
No. Why did you assume that those were both false?
If there's no repeated factors, then it's going to alternate.
If I have time, I'll go back, I'll make up one. It's not hard to make up one. That's a true, true, false, or a false, false, true situation. But and if I don't have time to do it today, I'll do it maybe on Monday.
So,
We'll express using interval notation.
And how many intervals are we going to have? Well, there's only one shaded. So what am I going to write? What's the first symbol I write? Bracket or parentheses? Bracket, negative 4, comma, 7, and bracket.
An interval that starts and ends with a closed circle is called a closed interval. This is a closed interval.
Mm-hmm.
So
you only experiment with that end? Like if it's closed, you only, I'm still confused why those other ends were closed.
Oh, what, these?
Because you
oh wait,
only,
wrong thing.
Because of the equal
Wait,
sign.
what am I doing?
Step
I gotta go to
one.
your paper.
Step 1, when you find the solution cut points, if there's an equal sign on the symbol, use a closed circle. If there's not an equal sign on that symbol, use an open. So we look at the symbol. There's an equal sign. So there's closed circles at these numbers.
and so you only can play with those numbers between -4 and 7.
Those should be the only ones you have labeled.
Okay.
Those are the
Okay.
only ones you can plug in to make the left side less than or equal to the right. These are the only
These
numbers
numbers.
that'll satisfy that
If
inequality.
you chose anything bigger than 7, if it were open, then it just wouldn't
Okay.
include those numbers.
That's why I was confused.
Okay.
Thank you.
Oh.
But I'm afraid you think that -4 and +7 are the only numbers that satisfy the inequality. It's every number between -4 and +7, including those endpoints.
Right.
Like -3 and -pi. That would be right out here. That satisfies the inequality.
But because since it's true, that's the answer. But you could never look at the infinity negative, between the infinity negative and -4. Like we
Well,
did.
you wouldn't
Those-
type it as a solution,
Okay.
but
Because-
if you tried something like -5 or -10, you'd get a false statement. You can go home
Let's
and
do
try.
this one. Between 7 and infinity, why aren't we
Test
listing
10.
that? Let's test 10. If I put a 10 in here and here, we'd have 10 times, what would be in the parentheses?
7.
7. 10 times 7, is that less than 28? No, and it's not equal to it either. So these numbers make it false. So do these numbers. But you don't need to test every interval the way I did on the first one. Okay?
But you can if you
You
want
can
to.
if you want to.
And if you're going to only test one interval, you better make sure you test it correctly.
But
Because if you-
I found that students seem to mess up more often testing every interval than testing one interval that's, if they're testing with a number that's easy to use. Because there will be some eventually where maybe the intervals, the cut points are 5 and 6. If you're going to test that interval, you're going to have to choose a decimal number between 5 and 6 to test it.
Use the brackets from your keyboard. Bracket, -4, comma, 7, right bracket. Any questions there?
Pretty much every one of these takes a different page. Or I'll be writing on a different page. I don't like to start it on one page and go to another. Let's do number 5 now.
I'll do this.
Okay.
I'll let you do this.
Well, you're
Just
gonna have to
stand up. I'll tell you one day.
I'm raising this paper.
One day. What's this? Huh?
Oh, well,
Okay. Number 5. X divided by x plus 4 is less than or equal to 2. X divided by x plus. Okay, let's switch to my paper.
is there going to be a denominator cut point on this one?
Yes. Okay, first thing we do, we find solution cut points.
If you're a view and example person, sometimes they find the denominator first, sometimes they find the solution. Doesn't really matter which one.
And I don't think they call it that terminology, solution cut points and denominator cut points. They just say numbers on the number line. I like to have names for things. First thing we do, we replace the inequality with an equal to, and let's see, okay, I need to get rid of that fraction. What do you think I'll do? We're going to multiply both sides by x plus 4. It's the only denominator that appears. Let's multiply both sides by x plus 4. Hey, Tony, we're going to put that as a 2 over 1 and cross multiplied. Cancel the x plus 4. That'll give us x equals, what are we going to have on the right-hand side? What are we going to have to do over here? Distribute there and there to give me a 2x plus, I couldn't hear you? 8. 2 times 4, I agree, is 8. Is this quadratic? Are we going to have to factor? No. It's going to alternate then. As we look through, we're not going to have any quadratic factors. Look at that denominator. We're finding the denominator cut point. There's no x squares. You're not going to have to factor there. So I'm already feeling better about this problem because I'm thinking I only have to check one interval. So you have to find all the cut points. I think I'll move this x over to the right and combine it with that 2x. What's that going to give me here? Be careful. Okay, good. You're going to do minus x. So we have 2x minus 1x is just an x. Now let's move that 8 over. What's that going to give me? -8. I just found my solution cut point of -8. Open or close? What did I do with your little page, Tony? It contains equality, so I agree. It's going to be closed when I label it on the number line. Any questions on our logic there? Next, set any denominators you see in the original problem not equal to 0 and solve for x. These numbers are called denominator cut points. We never want a denominator to be 0. Remember I said the first step is asking where is the inequality equal. The second step you're finding where is it undefined. Well, the fraction's undefined when the denominator is 0. So I think I'm going to do the DCPs right here. What do you think? Set x plus 4 not equal to 0. What's that going to give me? X cannot equal -4. This reminds me of when we were solving those rational equations and we were asking ourselves what numbers would be unacceptable. We couldn't let the denominator be 0. You never want x to equal -4. Look at what I say here for step 2. Always label denominator cut points with an open circle. You never want a denominator to be 0. So that it doesn't matter what the original inequality is. Denominator cut points are always open. For solution cut points, you have to look back at the original inequality. -8 makes the left side equal the right side. Is equality okay here? Yes. So the solution cut point is closed. Denominator cut point always open. Any questions on our logic there? Third step, draw a number line.
And label these numbers in numerical order.
Don't say anything. Tony, don't answer. Well, you can ask the question because you have the microphone. It sounds better.
No.
Which number am I going to write here? I couldn't hear you. -8. That's smaller. And once again, when I say I can't hear you, I just can't hear you. It doesn't mean that.
Hopefully you can tell the difference between the infinities and the 8.
-8. How am I going to label that? Closed. We said the solution cut point is closed. Denominator cut point. Okay. Denominator cut points always open. Solution cut points closed. Notice there were no perfect square factors. You didn't even have anything to factor here. Everything resulted in linear expressions. So it's going to alternate. If I were running out of time and this were a test, I'd either guess. I have a 50-50 shot. It's either going to be true, false, true, or false, true, false. But I'm not running out of time. I don't have to guess. I'm going to choose a number and test the interval. What number is my favorite number to test? 0. 0 is easy to plug in. Which interval contains 0? Interval 1, 2, or 3? Number 3. So
0 is always between a negative and a positive number. When the semester is over, when someone finds out that you had one of the Mr. Precellas, or maybe even both of them, they're going to say, so you had Mr. Precella for algebra. Tell me something you learned. And you'll say, I can locate the number 0
on a real number line. Because this cut point stuff, whenever our assignment, we only have 13 problems in this assignment.
Put another cut point.
Stick a cut point problem on it. This stuff will not go away. I doubt there'll be a week of class where there's not going to be a cut point problem stuck on some homework assignment from here on in, okay?
So you don't forget it. And that way,
testing 0.
Plugging up here.
We're plugging it in up here. 0 over 0 plus 4 is 4 is less than or equal to 2. What's 0 divided by 4? I couldn't hear you.
0?
0. I agree. True or false? True. So what do we do here? Well, we put the T. I'm going to shade it.
Now you know the answers for the others.
Here, if I tested -5 there and there, would it be true or false? False. Suppose I tested a number over here like -10, would it be true or false? True.
Well, once you know one of them,
Like,
it
how do you
alters.
know that that's false without testing? How do you know that that's true without false? Like, people's minds work faster than mine, I guess.
Oh, no.
Okay, we've told you, I'll try to make if I don't have time to get an example done, I'll just make a video showing what happens when you have repeated factors. If you have repeated factors, then, I could create one. I can make up one as repeated factors. That's a true, false. But y'all don't counter it in your homework. But I'll make up one just so you can see it. Could happen. But If it does, the thing is factorable and it has perfect square factors. There wasn't even anything here factorable, but if that's bothering you, you check. Choose -10 here, choose -7, 6, or 5 there.
I don't know what you mean by repeated
The
factors.
same numbers. When you factor, well, first of all, if you don't factor anything, then if you have the same thing in both sets of parentheses, when you factors, that's when it might not alternate. But here, is this x minus 6 repeated here in this set of parentheses? No.
Over here. Or the factors repeated, x minus 4, x minus 4.
No, x minus, oh yeah.
Or x minus 7, x minus 7, x plus 5, x plus 5.
Okay.
No, that's what I mean by repeated factors.
Here's that picture.
I don't
There
know.
it is.
Someone wrote me
Oh no.
a letter. Okay. Express the shaded interval using interval notation. I want you to call it out as if you were typing it in. What's the first symbol? I'm starting at a negative infinity. What am I going to have first? The first thing I type. Parentheses. And then I'm a negative infinity. What do I have to put? Comma. You've got to put a comma between those. -8. What am I going to put after the -8? It's closed in here, so what are we going to get? A bracket for a close. Let's see, use brackets for closed circles. Really, that's all we could say. Use parentheses everywhere else. You only use a bracket at closed circles. Maybe that's
brackets for closed circles.
Use parentheses everywhere else. Maybe that's what we should start saying. So bracket. Then you have to use the little union to say set union or call out this one. Am I going to have any brackets on this second interval? No, because there's no closed circles. I'll have a parenthesis, comma, an infinity. Okay. Any questions there? Where is it equal? Where is it undefined? Label the numbers on a number line. Test the inequality. Test one interval. And interval notation.
So parentheses, negative infinity, comma, -8, square bracket, union, parentheses, -4, comma. Don't hit space keys. Hitting space keys sometimes messes up the format.
Sometimes you hit the space key and it does nothing. I like those.
I'm going to go back into number 4.
Any questions here? Let's do another fraction, number 4.
Will there be a denominator cut point? Yeah.
Oh, I have a good question. Let me write the problem down first, then I have another question for you.
Oh, I know what your question's going to be. Are we going to have any brackets in our final answer?
What's the question? God. No, there are no brackets because... Okay, that little thing is just a greater than. There's not going to be a closed circle at the solution cut point, so no brackets. When you're typing it in, it's all parentheses.
My brother and I had the same math teacher, and the first time we saw solving inequalities like this, the teacher's method that she used was called
Think about it. Just think about it
until you came up with this answer. Anytime a math teacher resorts to just think about it,
they don't know how to explain it, okay? And I'll tell you the funny thing, there's a funny story about this method, the cut point method. I'm not going to tell it while I'm being recorded, okay?
The
But
first time I ever saw the sequence of steps, I thought, oh my gosh, why didn't she show us this? And my other question, why didn't I look back then? We had paper books. Why didn't I actually pick up the book and look through, and the book had the steps to it? I'm pretty sure the book didn't just say think about it, but there we were thinking about it. I'll tell you, following a recipe is a heck of a lot better than thinking about it.
But
Okay,
okay, first thing,
find those solution cut points.
you know something? I'm going to rewrite -3 over x minus 5. You replace that greater than with an equal to -1. You know what I think I'm going to do? I'm going to cross multiply. I can make this into a fraction equals a fraction. I could have done the same thing right here, put the 2 over 1 and cross multiplied. But I didn't do that. I'm going to do it here though. Y'all see what I'm doing? I'm setting it up so we can cross multiply.
Still get the same answer.
Still get the same answer. I just want to illustrate there are two different methods for solving these equations. Multiply by the denominator on both sides, or cross multiplying. Now if you're going to cross multiply, it's got to be in the form fraction equals a fraction. That's why I put that -1 over 1. So here we go. -3 times +1 gives me a -3 equals -1 times x minus 5. What's that going to give me? Maybe I better write it out and let y'all tell me. Okay, I heard it. -x keeps going. Okay, I heard -x and what else? Okay, I agree. You're distributing that -1. Notice the equation, the resulting equation is not even quadratic. It's linear. You're not going to have to factor, run into the possibility of picking up repeated factors. So I'm feeling good. This is going to be one of those where we only have to test one interval. We're trying to solve for x. What's the smart way to do the solve for x? What do you think I'm going to do with this term? Okay, because then that -x will become...
You know, move that x over, you know a good amount of algebra.
Okay, and here...
Oh,
Okay. And then what else? I was about to say it. Y'all tell me.
So move the x over.
I move the x over, and now what am I going to do? Add 3, 5 plus 3, that gives me the 8 for my solution cut point. And what did y'all say? Open or closed? Open. Okay, so that was step 1.
Finding the solution.
Finding the solution cut point. I'll just number the steps. I don't know why I've started numbering. I don't number. Second step, denominator cut points. Set any denominator you see not equal to 0. So x minus 5, you don't want a denominator of 0. What's that going to give me? Okay, so we move it over. That minus 5 becomes a positive 5. For my denominator cut point, how are we labeling it? Always label denominator cut points open. You never want a denominator of 0. Third step, what am I going to do? Okay, number line.
Oh, now here it's pretty easy to label the cut points in numerical order.
So we have 8 and 5. Here I'll have 5, 8. Put them in numerical order. Okay. Which number do you think I'll test? 0. I'm testing intervals right now. Which interval contains 0? Interval 1, 2, or 3? 1, I'm testing 0. 0 is between negative numbers and a positive number. So plugging in 0, I'm going to get negative 3 over 0 minus 5 is negative 5. Is that bigger than negative 1? Negative divided by negative is positive 3/5 is bigger than negative 1. Yes, that is a true statement.
See, positive is always bigger than negative.
So we shade here. Suppose I tested 6 or 7, what would I have done? Shaded or crossed out? Crossed out. Suppose I tested 9, 10, or 20,000, what would I do? Shade it. Oh, fifth and final step, I got to write it using interval notation. So maybe I need to lift this up a little bit, like that. There, right up there. Okay, I'll write it right out here. Call it out. Am I going to need a U in my answer? Am I going to need a union?
Yes.
Yes. Call it out as if you were typing it in. Here's step number 5. Okay.
Infinity, comma, 5.
Okay. Parentheses, negative infinity, comma, 5.
Union. Oh, then parentheses union. And then parentheses 8, comma, infinity, and parentheses.
Okay. Any questions there?
And if you do have some, well, I have 3 words to say. What are those 3 words?
Join the
You
club.
got it. Think about it.
Oh, I didn't get that.
Oh gosh, I remember.
Okay.
Wow, I felt so stupid at the time.
And then we had to do those teacher evaluations at the end of the semester. And guess what I wrote? Did the teacher have any pet peeves or something? You know what I wrote? And it was handwriting. Why did I do this? I know he knew who it was.
Because back then, at
What
the
did I
school
write?
we were doing, they were wanting to
Think
know.
about it.
They asked, "What's your major?
Yeah,
What's
yeah.
your GPA?" Well,
How
2
many?
people with math majors and a GPA of 4.0. Oh,
Well, that sort of limited
they
it
knew it
down,
was
didn't
and
it?
I couldn't believe it when he said, "I wrote think about it on there." And I said, "Oh wow, Tim,
Okay.
how to make a teacher dislike you?" Well,
Okay. How about some absolute value
no,
inequality?
number 6. We gotta get
Oh,
that one.
number 6. Oh, this is a good
So we
one.
gotta pick up the speed.
Okay, here we go. Number 6. Z divided by Z minus 8 is greater than or equal to 2Z. Okay, let's switch it.
Since I see that equal sign on there, I'm thinking there'll be some brackets in our final answer.
Yeah, that equal sign makes me think the solution cut points are going to have brackets. Replace the greater than or equal to with an equal. And I think I'm going to use cross multiplication again just to illustrate it. This is a really good problem to cross multiply. But I'm going to have to rewrite that 2z as 2z over what? 1. And then we multiply and multiply. Z times 1 is just z equals here
2z times
z minus
is
8. So that's a 2z squared, I agree, minus. You're distributing the 2z times the minus 8. That's a minus 16z. Uh-oh, it's squared right there. So I think we're going to we need to solve this. I think we can factor it, but regardless, you're going to have to get it set equal to 0. What do you think I'm going to do with that thing there? Okay, I'm going to subtract I don't think we're going to have to use reverse FOIL because I don't
You're
think
making it harder than it is. I think it's going to factor pretty easily.
subtracting that z from both sides, we have 0 equals 2z squared minus negative 16z minus 1z gives me.
No,
I think this isn't a trinomial. This is the most basic type of factoring in Math 371. It's the first factoring we do in that course.
but I think also that we haven't done one like this.
I don't think so.
So far this semester, we've had that constant there and did the little reverse FOIL
You're
trial
right.
there.
Mm-hmm.
For here, if there's not a constant, this is easy.
You're reversing the distributed property.
Factor out the variable. Does that phrase sound
Both
familiar?
of those have a common factor of z. We can take out the z. Z times what will give me 2z squared? 2 and a z, I agree, minus z times what gives us that 17z? I agree with 17. Y'all remember factoring out common factors somewhere along the way? It's just reversing the distributed property. If you can distribute, you can do this type of factoring.
It's easier than that
Foiling.
spoiling thing that we were doing. But there is one thing tricky about this. Once you have it factored,
You set the factors equal to 0. You set that first factor equal to 0.
yeah, you got to set the z to 0 also.
It's already solved for 0. I mean, it's
Okay,
already
Z.
solved for z. There's my first solution cut point. Set the 2z minus 17 equal to 0. That says 2z is equal to 17. So z is equal to 17 over 2. There's my second solution cut point. And how are we going to label these solution cut points? I'll give you a hint. It's either open or closed. Okay. These numbers make the left side equal the right side. Equality's okay, so I agree. Closed circle.
You have an equal sign in the original problem. For the solution cut points, use a closed circle. Now when he finds the denominator cut point,
Okay, setting any denominators not equal to 0. So we set z minus 8 can't equal 0. That means z cannot equal what? Positive 8. That's my denominator cut point. How will I label that on a number line? Do you ever want a denominator to equal 0? No. So how will I label it? If you're not sure, the recipe says it. Always label denominator cut points with an open circle. Notice as we went through the factoring stage, did we get repeated factors? We had a z as one thing, a 2z minus 17 as the other. No, we didn't get the same factors. We got, as a matter of fact, we got a monomial and a binomial. We didn't get the same factors, so this is going to alternate. It'll either be true, false, or false, true. That's what I mean by alternating. Third step, draw your number line. Negative 8, infinity, positive infinity. I have 3 cut points. Be careful how you label them. What's the smallest one? What's going to go here? 0. Okay, what's going to go next? What's it's going to be 8 or 17 over 2. 8, that's 16 halves. 17 over 2, that's 8 1/2. That is larger. If you punch into your calculator, I bet you 17 divided by 2 will give you an 8.5.
Let's see, while we're saying 17 over 2 is the one on, is to the right of 8. 17 over 2 is 8.5. So, oh wow.
And we said 0 is closed. Here, 8, what are we going to do? Open. Here, what's my favorite number to test? 0. Can I test 0? I can't test a cut point. I have to use a number that's in the intervals. 1. Okay, you see, that's what I said earlier. If I can't use 0, I'm going to use 1. Okay, where is 1? Is 1 at interval 1, 2, 3, or 4? 2, okay, right here. I'm going to test 1. That's going to give me 1 over 1 minus 8 is negative 7. Is that bigger than 2 times 1 is 2? I have a negative 1/7 is bigger than 2. True or false? Oh yeah, you're right. It is false. A negative number is never bigger than 2. That's false. So I'm crossing it out. That's false. So if I test a number over here, what would I expect to happen? True or false? True. So shade. Here? True. So if you test a number between 8 and 8.5, something like 8.1, you get a true statement. Here, false. If you test a number bigger than 8.5, it'd be false.
This would have been a good one to think about.
Okay.
I could see us thinking and deciding that all the numbers between 8 and 8.5, not including 8, but including 8.5, that's a solution.
Okay, so I'm just here writing down the answers. Tony's talking, so I wrote the parenthesis, negative infinity, comma. What goes next? Parenthesis or bracket. Be careful. Bracket, because it's closed. Next, union, parenthesis or bracket. Parenthesis, 8.
Comma, 17 over 2, bracket.
Okay.
Let me start trying to type that in. Parentheses, negative infinity, comma, 0, bracket, union, parentheses, 8, comma, 17 over 2. Be careful, don't put the bracket down there. I'll hit right arrow to get out of that denominator, and then put the bracket. And check it. Okay. Any questions on this one? This is a doozy. If you can do this one, you can handle the rest of them.
I need to pull that up some more. Do that. There. To move it. It all fits there.
Oh, wait. Oh. There.
Any questions? Absolute value inequalities. Remember the last time we said if you have an absolute value equation, you need to get that absolute value isolated before you do anything else. And so that's my advice to you for absolute value inequalities. Tony, you want to take over for a while?
Yeah. We'll do number 9. I want to do one where you got to isolate first. Number 9. I think if you remember correctly, the solving absolute value equations wasn't that difficult. That assignment.
And notice this is different from what you were doing the last time. The last time it had the equal sign there. Here it's a less than. If it adds a less than or a greater than, you're going to be drawing a number line and testing intervals, okay? But what's the first step in the cut point method? You're going to have to replace that less than with an equal to. That's why we did the equation step first. And remember what we said the last time. You want that absolute value by itself before you try to make any decisions. So when I look here, the first thing I see is that absolute value isn't isolated. I'm going to isolate it before I even start the cut point method. What do I need to do to isolate that absolute value? Add 10. Oh, well, wait, I better go ahead and... Have you written it down? I said I was going to let you do it, and I'm still here talking and talking, so I'll be quiet.
Always, always, always isolate the absolute value bars first. Like over here, we had to move the 6, and there were some other ones. But here, as Tim has already said...
So before you equal it?
Before you do anything. First thing, if you have absolute value bars, first thing you always, always, always do is...
isolate it.
In that case, I'll add 10 to both sides. So we'll have absolute value. I'm trying to make it so it doesn't look like 15x plus 21. Absolute value of 5x plus 2 is less than... What number should be on the right-hand side? 7.
I agree.
Now, do we have any denominator cut points? No, there's no fractions in the original problem.
You know, my advice, Tony,
What?
for ease of checking, as soon as you've isolated it, I marked that original problem out. It's gone. I'd never look back at that original problem.
Yes.
When you're checking, check the isolated form. That makes it easier. There are fewer chances for mistakes. But isolate that absolute value. And sometimes that absolute value already be isolated. I bet you on number 8 it was already isolated. That's why we skipped over it.
Yeah. And 7 and 8.
7 and 8.
9 is a good at first example. So
first step.
we're going to solve it as if it were equal. And y'all remember how we did this stuff when it was equal the last time. What would we do? We'd go
That's it. I was
equal
at that
positive
meeting.
equals negative.
I remember that now.
Yeah,
I was
you
at
weren't
that
here.
meeting. I was here thinking,
So-
okay.
So here, what are we going to do? To solve it with an equal sign, we're going to go equal, like over here we went equal 15 and equal negative 15. What are we going to do over here? Equals 7 and equals negative 7. So 5x plus 2 equals 7, and 5x plus 2 equals negative 7. What I'm doing here is finding the solution cut points. Now, do I have to do any sort of factoring here? No, so it's going to alternate. Okay? So how do I get this x by itself? I would subtract the 2, so we have 5x equals 5. Divide by 5, so my first solution cut point is x equals 1. Now let's come over here, subtract the 2, so we have 5x equals, is it going to be negative 9? And then do what? Divide by 5. Oh, so this cut point here is a fraction, negative 9 over 5. For the solution cut points, you look at the symbol. There's not an equal sign on it, so what are we going to use? Open circle. Are we ready to draw the number line now?
Once again, there's no fractions in the problem, so there's no fractions in the inequality, so there's no denominator cut points.
Is it pretty easy to figure out which one is closer to negative infinity? Am I going to put the positive 1 or the negative 9 over 5? Negative 9 over 5, open circle, positive 1, open circle.
Can I test my favorite number here? 0? Yeah. Okay, which interval contains 0? Interval 1, 2, or 3? 2.
0 is always between a negative number and a positive number. So, plugging a 0 into this right here. 5 times 0 is 0, plus 2 is 2. Now, before you decide true or false, actually take the absolute value. The absolute value of 2 is 2. 2 is less than 7. True or false? True. So I'll shade. Are y'all caught up? I'll shade this one. And what will I do with the other 2? False them out. So, will I have an infinity symbol? Will I have to type an infinity symbol in my not infinity. Well,
Yeah, an infinity.
yeah.
A negative.
Okay, I was meant union. So
Will
what
we
am
have
I
to type a union? No. Okay.
So I go.
Call it out as if you were typing it. Give me the interval notation.
Negative 9/6, comma, 1, close parentheses.
Mm-hmm.
Any questions there?
So for the absolute value inequalities, just isolate them. Then go equal positive, equal negative. Test an interval. So
Come over here. Oh no, I'm coming over here. I'm going to top. So parenthesis, negative 9/5. Get out of the denominator before I type my comma, 1 parenthesis. I wonder if I'd put that parenthesis, that comma in the denominator, would it have accepted it? What do you think? Y'all want to see?
no, we don't have time to see.
Okay, you're right.
Okay.
Even if it does, the next one, it's just
Might not.
programmer's choice. The next one may have been done by a different programmer and they would not have accepted. Don't put commas in denominators.
Move over to put the. Look, I didn't put the comma. If you look at my work, I don't have the comma down here beside the 5 and the denominator.
I know, that's
It's
right.
in between them.
Good.
Now, let's go ahead and do number 11.
Oh, you think they're ready?
I don't know, but
I think they're
this
ready.
is one of those times when I'm always considering turning off the view and example. If you're in a view and example sort of person, go home and do problems 11 and 12 right now. Don't wait and have to look at
Let
view
me
and example
point out
later.
something to them. Let me point out something to y'all. Suppose going back to this problem here, number 9, suppose instead of a less than, it had said a greater than. Suppose it said a greater than.
Would it have been a harder problem?
Would it have been a harder problem? No. The only difference, if that had said a greater than, instead of shading, what would we have done right here? And then here, shade and shade.
What they do with problems 11 and 12 on view and example should be criminal.
I mean, I cannot imagine why or what
They
were
use
thinking.
some rules that we don't state, and
That only apply to linear expressions, but they try to expand it to quadratic absolute value expressions, and in the process, they get the correct answer, but if you change the greater than to a less than,
their method won't
their method
work.
is meaningless. So this is really one of those bizarre situations.
But we can't turn off view and example for just two problems.
But
We either turn it off where you don't ever see it on the assignment, or it's on there. So my advice, do 11 and 12 so, while you remember it. And you know what, maybe we should have put a hint on it. Don't look at view and example. We could have done that.
we could, no, we can't.
No, now we
Because
can't, but we could have before the semester started.
Okay. Are we gonna have to move anything around?
Or the absolute value bar is already isolated?
Yes,
They're already isolated.
They're already isolated, and so that's nice.
We're going to go and start, just like over here, we went equals 7 equals negative 7. What am I going to do here to find these solution cut points? Equals 14 and equals negative 14. Okay, so
Try to write small.
x squared plus x minus 16 equals 14. I had a bizarre dream last night where I was doing this problem and I couldn't get it all. Anyway, it took pages and pages, and it was just a very bizarre dream. I normally like to do the equal positive, equal negative, like this, 2 columns, like I was doing the last time. And in the dream, I couldn't get it done like that. It was just a very bizarre dream. So anyone thinking out there they're going to be a math teacher, now you know what sort of bizarre dreams you'll have.
My bizarre dreams are that I'm standing up here and the class won't shut up, and I start cussing. And I'm thinking to myself, I'm going to get fired for this language, but I can't shut up. And so that's my bizarre
I have those dreams also. But last night it was about this particular problem. So you'll see equal 14 equal negative 14. What's different about this one?
What's going to make it longer?
Okay,
so we're going to have to get it set equal and factor. That weird method they use under view and example, you still have to do that.
Well, let's hurry and we'll pull it up so they can see it.
I'm going to pull it up in a moment once we're through with this.
There.
Okay.
If I subtract the 14, I have a minus 30 there. And let's see, can y'all get this factored without too much trouble? I'll give the programmer credit with this problem. It doesn't matter how they change the numbers, it always gets you something that factors really nice. It's brilliant programming. So we got.
I just don't like the view and example.
Yeah.
I love the problem.
X and X.
X plus something, X plus 5.
Okay, plus and minus. And I heard 6 and 5, so I'll go 6 and 5. Or if you want to write 5 and 6, however. How should I arrange that plus and minus to get a positive 1 as the middle term? If we put a plus in front of the 6 and a minus in front of the 5, if we FOIL it out, we'd have x squared, and then plus 6, a positive 6x minus 5x. Is that giving me a positive x? Yeah, positive 1x. And then, or the last two terms, if we multiply those, is that giving me the minus 30? Yeah. So, okay, it's going okay. So, my first solution cut point would be negative 6. The second one is 5. And let's go ahead.
Open or closed?
Let's go ahead and decide between open and closed circles right now. You look at the symbol, and what do y'all decide? Open. Okay. Now.
But as you go through this, keep in mind that other view and example method, you still got to factor.
Oh, yeah. In fact, I think they just didn't really know what they were doing. If you're doing these right, how many number lines should you draw throughout the problem? Just one. If you look at the view and example, they had three number lines before it's all over. You know what method they were using?
Think about it.
Think about it. That's what they were doing. Okay, so move the 14 over. We'd have x squared plus x. Is that a minus 2? Adding the 14?
That's sort of hard to read. That
oh, I'm sorry.
Let's take that green pen. I think it's going.
Oh, okay.
It is? Oh, yeah, it's going.
Okay, I'll just switch to blue now. Okay, let's draw my two sets of parentheses.
What do we know about the signs? Plus and minus. Oh, I like that too. Come on.
What 1 times 2? Let's see, how should I arrange my plus and minus to get a positive 1x out of this? Do y'all agree with a positive 2 and a minus 1? Set each one of these factors to 0. So we get a positive 1 and what? Negative 2. All of those are going to have open circles.
How many solution cut points do we have there?
4.
So that'd be 5 intervals. But let's look back at the factorizations. Are we going to have to check every one of those intervals? Do we have repeated factors?
X plus 6, x minus 5, those are different. X minus 1. Look at the 4 sets of parentheses. Are they all different? Yes.
Now, in order to get repeated factors, it would have to be a perfect square trinomial. So you would have needed something like a 25 here, and then you have 5 and 5. Or 16, and you use 4 and 4. When I saw that number right there wasn't a perfect square, I knew it's going to alternate. Even before we started factoring, I knew it.
You might be thinking a bit higher than they are.
I may be thinking it ahead, but...
Okay, let me draw a number line, and we got to make sure we get these numbers in numerical order.
Any questions on how we know it's going to alternate, or what I'm looking at, that lets us make that decision that we don't have to check every interval? I'm looking at the factorizations. We didn't have the same thing here and here. We didn't have the same thing there and there. That's what I'm looking at.
Okay, how do I label these numbers? Which one's closest to negative infinity? Then negative 2, 1, 5.
You can check 0.
Yes, and which interval would it be? First, second, third, fourth, or fifth? Let's see. 1, 2, where's 0? In the third one, it's between the negative and positive. So I'm going to say test 0. Now this one gets a little tricky. When we plug a 0 in for x, and you might say, well, why is it tricky? 0 squared is 0. So 0 plus 0 minus 16, what number's inside here?
True or false?
But you've got it.
Let's see if they make the mistake. Now they won't say anything. Okay. Okay, good. You've got to take the square root.
No, not the square root.
The absolute value.
You've got to change this absolute value of negative 16 just to a 16.
You'd be surprised how many people would say false. They don't take the absolute value of negative 16. The absolute value of negative 16 is a positive 16, and yes, that's bigger than 14.
So true. So shade it. Oh, wow. Cross it out. Shade it. Right here, cross out. Shade. Would we have done the exact same thing if this had been less than? Yes, that is the amazing thing about this cut point method. It will solve any type of inequality.
What they do in view and example is meaningless if the greater than is changed to a less than. Their method doesn't work under view and example. So, are we going to have any brackets in our interval notation? No, because there are no closed circles.
Let's see if what am I up to. So negative infinity, comma negative 6. Union negative 2, comma 1. Union 5, comma infinity. All parentheses. I'm just saying that instead of open parentheses, closed parentheses so many times.
What is this thing here?
I think it's a speaker. I'm not sure.
Then why is it sitting there rather than facing out?
Okay. Typing
it in.
If you can do this problem, then you can do a problem that a lot of algebra students can't. Okay.
Union, left parentheses, -2, comma 1, right parentheses, union.
Years ago, I remember an employee here telling me that they'd seen my cut point method and this little recipe, and they said, wow, it really works for everything. I don't understand why it works, but it works. Now I remember being alarmed, thinking, oh wow,
He doesn't see why it works.
you don't understand why it works? Oh, maybe you should have. Now look at this. Once he types in the answer,
Then they give me these number lines. They want me to choose the correct number line. I knew there was a spot. They're not doing the open and closed circles. They're putting brackets for closed circles
And I
and
think she said
parentheses
B.
for open circles. And which one do we choose? And that's when you say B. Okay. Just be aware. They're putting
I think they would
parentheses
figure it out.
inside of in place of that.
oh. Now, the next one is exactly the same problem, but with different numbers. You see, but I wanted to go back and look at the view and example. I just want y'all to see this nonsense.
This is nonsense.
It really is.
They start going.
Yeah, and here's my thoughts. I think that they just start going and they start writing stuff,
They knew the
knowing
answer.
somebody. They knew the answer. Okay, they thought about it. They knew the answer. But how do you program this?
Well, some
Okay,
of it-
and so they just started. They started going.
Look, first of all, look at your work. How many times did you write a greater than symbol in your work? Only when you tested. They're using these greater thans, and heck, they even bring in the less than.
Now they decide to bring in a less than too somewhere along the way, and then they start talking about polynomial functions. We haven't defined functions yet, but still, okay. They're gonna go.
There go.
They're going. They're calling the cut
They
points
factored.
boundary points.
This is where they factored the first two things. Okay, they're at that point. They get the first two cut points, and look what they do.
They draw a number line, and
oh my gosh.
now let's see. They're testing, and they come up with these intervals, but that's not the solution. Okay. Then they're going to do some more. They're going to
Start all over. Now they're at the point where we were factoring the second time. They get the last two cut
They get a
points.
second number line. I get some more intervals.
They're going to do some hocus pocus in a
And
moment.
they're thinking, surely people aren't paying attention. I'm going to pull out the answer in a moment. I know the answer, and so I'll just type it in there, and no one will have followed what I was doing.
They did it. Did they just pull up the
Yeah, they just did.
I think they got the answer.
I think they got the answer. And then they do the little number line, a third number line with the
So-
actual answer. It's just amazing. And I understand what they're doing. I'll be honest. I understand. They're modifying
These other little
rules for absolute values of linear expressions.
Which-
But it only works if that inequality is a greater than. If they change it to a less than, total garbage. Now look at this. If in place of that greater than, we had had a less than.
It'd still be exactly the same work, except right down here, instead of true, false, true, false, true, it would have been what? False, true,
true,
false, true,
true,
false. Nothing beats this little cut point method for solving inequalities. Okay? So, I think it's time to let him go with that. Okay? Any questions?
Give
We
me
tormented-
5
Listen.
minutes. I can
Yeah.
show y'all one that doesn't alternate, okay?
Oh.
I'm going to make up one,
Oh.
a real easy one that doesn't alternate, and you'll see what I mean by repeated factors. Let's say x squared plus 10x plus 25 is greater than 0, okay? Okay. A plus. They're both pluses. Set it equal to,
Notice there's no, what are they called? Denominator cut points.
I'm just trying to make a real easy one. I'm making up one that doesn't alternate.
Here's one that doesn't alter.
X squared, x and x. What do we know about the signs? Okay. 1 times 25 or 5 times 5? 5 times 5.
Y'all see what just happened? We got the same thing in both sets of the parentheses.
The only way that happened is this number here is a perfect square. So earlier when I had a 30 there, I said it's not a perfect square, it's going to alternate. So set x plus 5 equal to 0, and I get a solution cut point of. Okay. I don't even need to do that one because it'd be the same thing, wouldn't it? It's a solution cut point, open or closed. Open, no denominator cut point. I have a -5.
Because of this repeated factor, you can't just test 0. You need to test both intervals.
When I see the repeated factors, I'm going to test every interval. I'm going to write that out. Repeated factor, test both intervals. To the left of -5, what do y'all want to test?
-6.
-6, okay. To the right of -5, you know what I'm going to test over here, right? What am I going to test here? No. 0. 0 is my favorite number to test. I'm going to test a 0 there.
But 1 would have been fine.
1 would have been fine, but okay, testing -6. -6 squared, that's a 36 minus 60 plus 25 is greater than 0. What is that? 61 minus 60. I'm getting a positive 1 is greater than 0. True or false? 1 is bigger than 0. True. So, oh, by the way, I forgot to ask, what do I do at -5? Oh, I did. Yeah, I said open.
You're rushing.
I'm rushing, so shade. What if we test 0? 0 plus 0 plus 25 is greater than 0. True or false? True. 25 is greater than 0. True. So what are we going to do here? Shade as well. We had 2 consecutive true intervals. You cannot say negative infinity to positive infinity, though. You have to write it as 2 intervals because -5 isn't shaded. You're going to have to write it. I guess this is made up, so you're not typing it in, but if this were something on my math lab, you'd have to type in parenthesis negative infinity to -5, parenthesis, union, parenthesis, -5 to positive infinity.
So you just had to answer that question. What would
That's
you do?
what we mean by repeated factors.
Hopefully that made it.
Does that make it clear? Okay.
But, yeah,
Okay.
I just couldn't figure out how, but yeah. That actually kind of goes in class.
In a way, if you think about it, that's saying x plus 5. If you wrote it with an exponent, that's x plus 5 squared. No matter what you plug in here, when you square it, it's going to stay positive. It's those even exponents that mess up stuff.
But that will stop the recording unless there's any questions that you want recorded.